All right, everyone, welcome back to the last lesson of this unit, and in fact, it's this year. Um, Thank you for the journey, I guess, taking the journey with me. I hope you enjoy all the videos. Okay, so we are gonna be graphing rational functions today, and to graph, what we need is we need to get the information that we can get from the equation itself. So basically that's what we did last time. So we're just going to quickly go over an example, to quickly review. Now one thing though is, if you might have seen already, all the examples that I have are already in factor form. The questions in the book are usually not in the factor form, so make sure you factor first before you gather all the information, okay? Okay, so to find out the information, let me just list them out so I don't forget, I guess. Horizontal asymptote, vertical asymptote, slant asymptote, hole, x-intercept, y-intercept, and domain. Okay, so first of all, I'm gonna simplify this because I know I can reduce the x plus 2's. So I get 3 times x minus 4 over 5x plus 4. So clearly I would have a vertical asymptote, and that came from whatever the x value that will make the denominator 0. Okay, so I will not solve for x, but I mean, I didn't in my head. So hopefully you know how I got that number, negative 4 or 5. You simply solve this equal to 0 and you should get that. Horizontal asymptote, we will also get a horizontal asymptote here because the degrees are the same for both numerator and the denominator. And in that case, the horizontal asymptote would be the leading coefficient divided by each other. So in that case, 3 divided by 5. So y equals 3 out of 5. There's no slant asymptote in this case. We do have a hole because we reduced, or we simplified the x plus 2, right? We reduced that. We cancel that out. So the x value for the hole is going to be negative 2 because that's what makes x plus 2 0 there. To find the y value, we simply plug in negative 2 into x, and we see whatever we got is the y-coordinate. So this is going to be negative 18, and that is negative 6, so positive 3. Okay, x-intercept is found by making y 0, and recall from last video, I said that to find the x-intercept, basically you look for what's the x value that will make the numerator 0. In that case, well, I think it's clear, 4 minus 4 is 0. So x-intercept is 4 comma 0. Y-intercept is when you plug in 0 into x, and if you put 0 into x, you should get 5 times 0 plus 4, that's negative 3. Okay, and then the domain is going to be not equal to negative 2 nor negative 4 out of 5, but it could be everything else. Okay, and I'm not going to worry about the range right now. Okay, not right now. Okay, so this is what we did last time. We gathered all the information, and today what we're gonna do is we're gonna actually, you see, it says to graph rational function, we need everything that we just did, right? We need all of those plus the behavior of the graph near an asymptote. Okay, so I think I briefly, I didn't really explain, but I kind of told you what it happens when the graph gets closer and closer to the asymptote. I think I told you the graph goes towards the asymptote as the x approaches to the asymptote. I'm going to show you with the table values today, okay? So here is the example. F of x equals to x minus 1 over x minus 2, and this is the graph. That's what it looks like. And so you can see there's a vertical asymptote at x equals to 2. So you can see these values are really close to 2. So this is looking from the left, and this is looking from the right? So 1.99 is close to 2, but that 1.999 is even closer. 2.01 is close to 2, but 2.001 is even closer. So these two, we're looking from the left side, and these two, we're looking from the right-hand side. And if you notice, if you keep reading here, it says as x goes to 2, okay? That's the arrow, as x goes to 2 from the left side. So we're looking at these two from the left-hand side. and we are gonna, well, it says, or it tells you already, y gets increasingly negative. I believe this is negative 99 and this is negative 999. Okay, so I plug in a little bit earlier and that's what I got. Okay, you can double check. So you can see y gets increasingly negative, right? This is much more negative than that. So we say as x goes to 2 from the left side, y goes to or approaches negative infinity. Okay, that's the infinity symbol, negative infinity. Okay, as x approaches, or as x goes to 2 from the right side, y gets increasingly positive. So I believe this is 101, this is 1001. So again, quite a bit bigger. So we say as x approaches 2 from the right, so that's, again, that's plus sign means from the right, this negative sign means from the left, y approaches positive infinity. Okay, and you can see from the graph, right, as the graph goes towards 2 for the x value, you can see the y value gets higher and higher. So approaches positive infinity. From the left hand side, as x approaches 2, you can see the graph goes downwards, right? It approaches negative infinity. So these are the facts that we're going to use to graph. Okay, so again, we need to figure out all the information. We put them on the grid, and then we're going to use the behavior of the graph near asymptote to finish the sketch. Okay, so the graph will always goes towards the asymptote at the end, right? M behavior, again, the key here is the M behavior as well, right? We're talking about here and here. We're talking about horizontal asymptote, the M behavior. Vertical asymptote, then when it's close to the vertical asymptote. Okay, so we are going to look at 3 different examples, and there's one practice question for you to do, one easy practice question. Okay, but I'm going to show you this example first. So right away, when I look at this, again, it's already factor form. I'm going to reduce this. Okay, so this is simply just 2x minus 3 now. So this is actually a linear function with a hole, right? Because again, we cross out the x minus 1s. So we do have a hole. Since it's a linear function, but you know what, I'm just going to write it. I'm going to write down everything here just in case I don't miss anything. But we do know there's nothing here, okay, because it's a linear function. Hole, x-intercept, y-intercept, domain, and range. This one's easy to find the range because we only have a hole. We don't have it. It's going to be continuous except at that point. It's a linear function, right? So hole, we cross out the x minus 1, so we know the x coordinate is going to be 1. The y coordinate is simply plugging 1 into x here, so 2 times 1 is 1, sorry, 2 times 1 is 2, and 2 minus 3 is negative 1. So there's our hole. X-intercept, that happens when y equal to 0, so we can solve this equation. You should get 3 out of 2, comma 0. Y-intercept, because this is the mx plus b form, so it's easy to tell, 0 comma negative 3. Domain, x could be anything except 1. And range, y could be anything except negative 1. Okay. You can see 1 comma negative 1, that's the only place where the graph doesn't actually go through, right? So now this is simply just a line. We have the y-intercept of negative 3, that is right here, 1, 2, 3 right here. We have the x-intercept of 1.5, that is right here. We have a hole at 1 comma negative 1, that is right here. So, and we represent the hole by drawing an empty circle like that, okay? And that's it. I mean, to draw a line, really all we need is 2 points. We now have 3, so that's more than enough. You just need to join these 3 points with a ruler. Be careful though, you don't want to draw the line through the circle, okay, the empty circle. So make sure you kind of skip, just jump over the circle, the empty circle, and then connect the line, the dots, I guess, and that's it. Okay, yeah, that's it. Pretty straightforward, I think. Straightforward. There's a practice for you to do. Or you should pause the video. I'm gonna pause it as well, and then when I come back, I'll show you how, the solution. Okay, hopefully you finished it. This is what I got. These are information I got from the equation, and once I have them, I put all the information onto the grid. And then again, because it's a linear function, I simply just join them together and that's it. Okay. Yeah, this practice question, hopefully not too difficult. We will get into a more challenging example next. Okay. All right. So now we not only gonna have a hole, we are gonna also have a vertical asymptote and a horizontal asymptote. Okay, both vertical and horizontal asymptote. Okay, so let's take a look. In this case, again, quickly I notice I can reduce the x minus 3. So then now the equation is going to be y equals 6x plus 1 over 2. I'm going to multiply this out, so 2x plus 10. Okay, so then, again, VA, HA, horizontal asymptote, slant asymptote, hole, X-intercept, Y-intercept, domain, range. This time is going to be harder to tell before we graph. Okay, so we will graph and then we'll see what it looks like. Okay, vertical asymptote. So clearly we do have one, that is right here, -5. Horizontal asymptote, just like the review question at the very beginning, we will have one, and this is going to be 6 because the degrees are the same. 6 divided by 2 is 3, so y equals to 3. Slant asymptote, we're not going to have one. Hole, we will have one. It happens at x equals, no, sorry, not -5. It happens at when x is equal to 3. So if you plug this in, this is 6 times 3 is 18 plus 1, so 19. And then 2 times 3 is 6. 6 plus 10 is 16. 19 over 16. You can put this into a calculator to get a decimal point. So then when you plot, it'll be easier. But for now, I'm just going to leave it like that. X-intercept, again, is making the top, the numerator 0. So in this case, it's going to be -1 out of 6, comma 0. Y-intercept is plugging 0 into x. So you plug in here, you'll see that it's going to be 0, comma 1 out of 10. The domain, x cannot equal to, what do we have, 3 and -5, but it could be everything else. Okay, like I said, range is going to be a little bit more challenging, so I'm going to leave it blank for now. We'll come back to that in a second. Okay, take a pause if you think I went too fast, okay? So think about what I did, but again, everything I did was basically from last lesson, okay? So now what we're going to do is we are going to put these information on the grid, okay? So first, I'm going to draw my asymptotes. We have vertical asymptote at -5. 1, 2, 3, 4, 5 right here. We have the horizontal asymptote at 3. Okay, so that is 1, 2, 3 right here. Okay, and now I'm going to change to a different color and draw the graph. Okay, so we have a hole happening at 3, comma 19 out of 16. I believe 19 out of 16 is 1.1 something, 1.1875. So here's 1, 2, 3, and 1.1875 is somewhere here. So I'm just going to make a hole there. We have the x-intercept of -1 out of 6, 0, that is right here. We have the y-intercept of 1/10, that is right here. And that is all the information that we have. Okay, so now notice we do have a vertical asymptote in this case. Now what happens with vertical asymptote is it kind of splits, or I should say it, well, yeah, because we only have one vertical asymptote, so it kind of splits the graph into 2 pieces, right? We have one part over here, and we have one part over here. Remember, if you look at the domain, it could be, wait a minute, oh yeah, that's right, it could be anything except these 2 numbers, right? So really, it's still gonna be a function where the graph is mostly filled, except at, you know, this vertical asymptote and at that point. So it's gonna be continuous, okay, except at those two x values. Okay, so now what we notice is we have this vertical asymptote. We do have some points on the right hand side. What we don't have is we don't have points on the left hand side of this vertical asymptote. So what we need to do is we are going to get a point. And to get a point, well, so we simply plug in the number and see what we get for the y value. Since this is -5, I'm going to plug in -7 for x and see what I get. Okay, I'm going to plug in negatives. So let me write down the expression here again. I'm going to plug in -7, okay? Plus 1, 2 times -7 plus 4. This is -41 divided by -10. So this is 4.25. Or, no, 4.1. I don't know why I said 4.25. 4.1. Let me just double check. -14. Yes, 4.1. Okay, so that means we would have a point at -7, so that's -5, and 4.1, so that's 1, 2, 3, 4. 4.1 is somewhere here. Okay. Okay, I think that looks good. Okay, good. So then that really is all we need, because we are now going to use the fact that the graph will always goes towards the asymptote to guide us finishing the graph. Okay, so as we know, as the graph goes towards the vertical asymptote, it will goes towards the vertical asymptote. Now you can see this is gonna go downwards like that. You can see, right? It's going downwards, so it's gonna go down like that rather than going up, because otherwise it doesn't make sense. Horizontal asymptote, the graph will always goes towards the horizontal asymptotes at the end, okay? Not necessarily in the middle, but at the end. So you can see it's gonna go up towards the horizontal asymptote, but it will not touch. Same thing on the left-hand side of this vertical asymptote. As x gets closer and closer to -5, it's gonna go up. Now you might ask, how do I know it's going up, not going down? Well, if you think about it, if it's going down, then we would have an x-intercept. But clearly, when we look for x-intercept, we don't have one in this area, right? We only have one x-intercept right there. So it's not gonna go down, it has to go up. And then again, as x gets more and more negative, it will go towards the horizontal asymptote. Okay, so now you can see the graph really, it covers all the y values except 2 of them, right? So I'm gonna go back to red. Y really cannot equal to 0. I mean, sorry, not 0, what am I talking about? 3, because that's our horizontal asymptote. It also cannot equal to the whole, the y value at the whole. That's 19 out of 16. But it could be everything else. Okay, so those are the only 2 y values that are not allowed in this graph, because you can see it keeps going up and keeps going down to positive and negative infinity. Okay, except it doesn't go through 3 or 19 out of 16. Okay, hopefully, I mean, you can look at this graph. This looks like what we did in the previous chapter. It looks something like that. Next example will be something quite different. Okay, now we're going to involve slant asymptote. Okay, so here's the equation. You can see there's nothing for us to reduce, so then I'm just gonna start writing all the information. Okay, so VA, HA, horizontal asymptote, slant asymptote, the whole, and then what else? X-intercept, Y-intercept, what else? Domain. Now range is actually quite tricky here. We are not going to look at a range when we have slant asymptote. Okay, that's okay. You can deal with that when you take calculus. That's fine. Okay, so vertical asymptote, I think it's clear. That's where we look at. X equals to -1. Horizontal asymptote, in this case, we don't have any because the degree on the numerator is greater than the denominator. In fact, it's exactly, the degree is 1 greater, which means we are going to have a slant asymptote. Okay, so we need to expand this. If you expand this, you should get x squared minus 3x plus 2. So x squared minus 3x plus 2 times by x plus x, subtract, you get -x plus 2 minus 4. Okay, so the rest doesn't really matter because that's what we are looking for. There is our slant asymptote. We don't have a hole because we didn't cross out anything. Okay, X-intercept, again, to do that, we need to make the numerator 0. In that case, it's going to be 1, 0 and 2, 0. For the y-intercept, you simply put 0 into the x. You should get 2. Okay, put 0. Yep, that's right. Okay, so double check, I guess, but I think it's right. Domain. So in this case, x cannot equal to -1, but it could be everything else. Okay, so that's all the information that we have. Okay, so again, we're gonna put these information and then onto the grid. Okay, so first of all, I'm gonna do the asymptotes. Vertical asymptote at -1, that is right here. Okay, and then we have a slant asymptote with equation, what is it, x minus 4. So 1, 2, 3, 4, that is right here. We go 1 up, 1 right, 1 up, 1 right, or 1 down, 1 left. So here, you know what, I'm just gonna use points. Or, you know, never mind. There you go. Here is your dash. Okay, so something like this. And there is the slant asymptote. Okay, now I'm going to change to a different color. I was use blue this time. And we have x-intercept of 1, 0. 1, 0 is right here. We have x-intercept of 2, 0, which is right here. We have y-intercept of 0, 2, that is right here. And really, that's all we have. Okay, so then again, you can see we only have one single vertical asymptote, which means we are going to split this graph into 2 parts. Namely, one part on the right of this vertical asymptote and one part on the left of this vertical asymptote. Now, on the right, we do have 3 points. So I think it's quite clear what it's gonna, well, I don't know if it's clear, but I think we can graph without a problem. Okay, so again, the graph will go towards vertical to infinity in this case, because you can see it's going up, right? It's gonna go down, come back. Now again, the graph will go towards the asymptote, so it will go, okay, that's kind of onto the asymptote. It's gonna go towards the slant asymptote in this case as x gets bigger and bigger. I'm going to draw a little bit higher here. So looks something like this. Okay. Now on the left hand side of this vertical asymptote, so really there are 2 possibilities. Okay. So it could either be here, this portion, or it could be here in this portion. Now we could get points, but I think for sure it's going to be here. And again, the reason being because we calculated for the x-intercepts. There were none in this region, right? So we don't have x-intercepts, therefore we don't have graph there. It has to be in this portion. But we still want somewhat accurate graphs. It's not going to be super accurate, but that's okay. We need some points. So I'm going to put, what was the x-intercept? The vertical asymptote was -1. So what I'm going to do is I'm going to put -3 in here. So -3 minus 1, -3 minus 5, -3 plus 1. This is -4 times -8 divided by -2. Oh, times. This is 16. Oh, kind of big. Okay, what if I put -2 then? What happens if I put -2? Might be better. Oh, wait a minute, I made a silly mistake. No wonder it looks weird. That's -3 minus 2. Why did I put -5? I thought ahead of time it was going to be -5. Okay, never mind. That's -4 times -5 divided by -2, which is 10. Okay, or -10. Okay, so we have a point at -3, -10, which is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here. Okay, we don't know if that's going to be the what we call the local maximum, but we do know it's going to go towards the vertical asymptote like that. It's going to go down again. It's not going to go up again. If it goes up, we are going to end up with an x-intercept there, but we don't have one, so it's not going to go up. And then I'm just going to go up a little bit higher, and then it goes towards the slant asymptote right there. Again, we don't know if that's going to be a maximum or not. I'm just assuming it's not. Again, you can figure out where the maximum or minimum is when you take calculus, but that's good for now. And that's why we can't find the range, because we don't know what this highest value is, or the biggest y value here is, or the smallest y value here is, because those are really not part of the range here. And so I'm not too worried about figuring a range in this example. Okay, so one last thing I need to mention to you. So this is what happens when you have one vertical asymptote. It kind of splits the graph into two pieces. What if you have like two vertical asymptotes? Well, in that case, I think as you can see from the previous chapter, you will then break into 1, 2, 3 pieces, right? And if you have 3 vertical asymptote, then you have 4 parts of the graphs that you need to think about, and so on. Okay, yeah, that's it. That's it for this year. I hope you enjoyed the videos. If you have any questions, let me know. It's been a pleasure. I had fun. It's different kind of delivery of instruction. But anyways, good luck with your homework assignments. Cheers.